Hello, everyone. Welcome back to AI tutorials, another session. Today, we are going to do more of practicals of, there will be a demo, a Python code, wherein you will use TensorFlow to define tensors, multi-dimensional tensors. But before we dive into practicals, just a brief intro of what is TensorFlow. It's an open source software library primarily used for machine learning and artificial intelligence, developed by Google, Google's brain team, and it is used in many AI applications. Okay, so the TensorFlow comes from a fundamental data structure, which is called as tensor. In today's practical, we will also see how to define multi-dimensional tensors. Okay, so its tensor is essentially a multi-dimensional array of numbers. At the what do you call at the very base, it's a matrix, multi-dimensional matrix. Okay, generalized version of matrices. Features, multiple features, flexibility, ease of use, a large community which keeps contributing to the libraries, wide range of applications in image recognitions, NLPs, speech recognitions. We'll be deep diving into that in future lectures, future coming lectures. Okay. So it is called TensorFlow because it handles the flow of what? Data and the mathematical operations of tensors. So tensors are nothing but a data structure, which you will see very shortly. Mm. And you can think of it as a multidimensional array. Tensors are represented as n-dimensional arrays of the base data types. It could be any data type, string, integer, float, any data type that you wish. Okay. The shape of a tensor defines its shape of defines its number of dimensions. Okay, so let's say if you have to the shape defines the number of dimensions, and the rank of a tensor provides the number of n dimensions. You can also think of it as an order of degree. So if you have to define the tensor data structure, here it is, very simple. It's a multi-dimensional array. I'm not going through the previous ones because we are going to do it in the practicals anyways. Okay, so tensor.shape, length, rank is the shape, and the d type is the tensor.type, which is the data type. Okay? Let's do some practicals. This was just a brief intro to what is a tensor. Now for that, what I'm using for the practicals, it's the collab.research.google, which is something you can think about it as Jupyter notebooks. So where you have each cell, and in each cell you can write a piece of code and execute. Obviously, the language we are using is Python. It comes pre-installed with a lot of things. You save a lot of time in not installing, having to install TensorFlow and everything in your laptop. Okay, so let's go ahead. What we'll be doing is defining a 0-dimensional tensor, a 2-dimensional tensor, and a 4-dimensional tensor. Okay, so you need the libraries here. We won't need the plot right now because we are not doing it anyways. But in the future coming lectures, we will need it. Basically, we need the TensorFlow library and the NumPy. So like Jupyter Notebooks, the collab.research.google.com, again, you execute the cell. Since this cell does not have any print statement, you don't see any output. If you can see it executed successfully by this green check mark, and what time it took, 0 seconds for it to execute this piece of code. So again, if the statements in the cell gets executed properly or without any errors, you will see this green check mark. Now defining a 0-dimension tensor, which is nothing but a constant. So let's say it's nothing but just like a variable. How you define a variable, it's just that. So sport is tennis, and of data type is string. Okay, so let's say number, some number, 1.4 blah blah blah, and which is of type float. Okay, and you're just printing. See the rank, it's a 0D tensor. Okay, the rank is how many as we saw, how many parameters, how many dimensions it has. So here it's a 0D tensor because it just has one value in it. Okay, no other dimensions. Now this is one dimension. See, it's an array with two values, right? Again, this is an array with three values. Okay, so it's a 1D with shape 2. So shape is basically the number of elements in the array. Okay? And the rank is what dimension array it is. So it's one dimension. See, sports is nothing but string array with two values, tennis and basketball. Numbers is a float with three values. So if you execute it, again, you see this green check mark and 0 seconds, and you see the output. Sports is a 1D array, 1D, tensor with shape 2. Shape 2 means two elements, okay? Numbers is a 1D array, one dimension with float type and three elements. Shape is 3. Now, higher order tensors, say 2D tensor. So you can see this is a two-dimensional matrix. So what you have done is I've defined an array, which is np numpy dot array, which is two-dimensional, 2 by 2. Okay, so which is of type int32 matrix, and now we're just printing the rank and the shape. So both will be 2 because it's 2 by 2. Let's make it some 5 and make this 6. Okay, and run it. So see, it's a 2D tensor, right? Because with shape 2 and 3. Okay, so it's a multi-dimensional, okay, with 2 and 3. 3 elements in each. Now here defining a 4 dimensions. Now see here 4D tensors. So first what we are doing is, see now another one, TF zeros. What it does is, it creates an element with all elements set to 0. So like how when we have, when we initialize a variable, right? Like if you use Java programming or programming in Python, first you initialize it. So what we are doing is initializing a 4D array. They're nothing but just images, okay, with 4 dimensions. So see here, now here if you do, it's a 4D tensor with shape. Each shape has 10 to 56 by 3. Now again here green check mark, time taken. Now these are just the assert statements which is used in testing, like, okay, whatever I've done, whether it's right or not. Like say for example, the rank of this numpy is equal to 2. If it was not 2, it would give false. Okay, so that was it. A simple lecture with introduction, very brief. Try to play with it. This is a free site, collab.research.google. Go to the site, and a lot of libraries are already installed, available. Try playing, creating multiple dimensional tensors and objects, okay? In the next class, we dive into more detail on how to use them in machine learning, okay? All right. Thank you all for your time. See you all again in the next class. Bye.